We start by looking at the sine function. So f of x equals sine x is a periodic function that goes up initially. It starts off increasing at 0, and then it peaks at approximately pi over 2, and then it comes down and crosses through at pi, and then we'll get to a minimum at approximately 3 pi over 2, and then it finishes back at 0 to complete its period or its cycle at 2 pi. Sine has an amplitude of 1. It varies between 1 and negative 1. So if we do the maximum minus the minimum, 1 minus negative 1, that gives us 2. If we then divide by 2, that gives us our amplitude of 1. And we can see that our midline happens to be the x-axis here. And from the x-axis, our function varies by 1 in either direction. The period, or how often it takes to repeat, is going to be 2 pi. It's hard to see because 2 pi is an irrational number, so I'm going to label it here. 2 pi happens a little bit after 6, and pi is where it crosses through over here, which happens a little bit after 3. To find the period, you can either look starting at the origin and see where it starts to repeat to get you 2 pi, or you can look between the peaks, and that will also give you approximately 2 pi. So sine has an amplitude of 1 and a period of 2 pi. Again, the maximum value is going to be 1, the minimum value is going to be negative 1, which gives us an amplitude of 1, and then the period will be 2 pi. Now, cosine is going to have very similar characteristics. Turns out, sine and cosine are the same function shifted by pi over 2. So it's not a surprise that they have a lot of similar characteristics here. So the cosine function starts its journey at 1 when we're at the origin, and it starts off decreasing, and it hits its minimum at pi, and then it comes back up, and it ends its period at 2 pi. But again, the amplitude is going to be equal to 1, because here the maximum value will be 1, the minimum will be negative 1, so the amplitude is 1, which means it varies by 1 from the midline. And again, the period is 2 pi. So remember that pi is a little bit after 3, and 2 pi is a little bit after 6. It's a good idea to know roughly where those are, because sometimes you have to make a good approximation, and pi is a pretty good guess if you're dealing with something a little after 3. So again, if we're talking about the maximum, the minimum, and the period, the maximum value of cosine is 1, the minimum is negative 1, which gives me an amplitude of 1, and the period is 2 pi. So the first thing we want to talk about in terms of sine and cosine, our periodic functions, is applying what we already know to these new functions. And one of the things that we know how to do is graph transformations. So let's go ahead and look at that in this context. Example 1. Use graph transformations to draw and describe how f of x equals sine x changes for each of the following scenarios. So we're going to look at 3 different scenarios to see how the graph transformation impacts the function. So you can see the graph of sine of x graphed here, and we want to graph 6 sine of x. So remember, if we multiply a number in front, that's going to stretch our graph. So instead of going up as high as 1, we're going to go all the way up to 6. And instead of going down to negative 1, we're going to go all the way down to negative 6. But we're still going to go through the zeros in the same place. So that's going to give us a little bit of a map here on what our function is going to look like. So here we're going to start off increasing just like we were before. We're going to turn around at 6. We're going to come back down at pi, a little bit past 3, go all the way down to negative 6, come back up, cross through pi over 2, cross through 2 pi. And then we can also backtrack over here because we know we're decreasing down towards -6 on the other side. So we've taken every y value and we've stretched it up by 6 units. Our next graph is going to be to take 3 sine x minus 2. So we need to take the 3 to stretch the graph by 3 units, and then we need to shift the whole thing down by 2 units. So we can do this in 1 step or 2. Since we're pretty new to this, I think it'll be better to do it in 2 steps. So first, let's start by multiplying everything by 3. So again, when we're multiplying by 3, we're still going through the zeros, but now we're only going to go up as high as 3 for our maximum, and our minimum is going to be -3. So we're going to come up, down, up, and then again, down over here. So that's what the 3 does. If we now want to take this function and shift the whole thing down 2 units, what we need to do is we need to track the important points here and move them all down by 2. 1, 2, 1, 2. And so we're going to have the same exact graph as the red graph, but shifted down 2 units. So our final graph will look like this. Now, of course, you're always welcome to graph these on your calculator to see if you're getting the same thing that you're drawing. Let's try one more. Our final graph starts with sine of x again, and now we want to shift it by pi over 2 inside the argument. Remember that when we shift on the inside of the argument, we're moving things left and right. And this one is counterintuitive, which means if we're adding pi over 2, we're actually moving left pi over 2 units. So let's figure out what that means. So here, pi over 2 is going to be roughly here where the maximum happens. So that means if we shift it left by pi over 2, our maximum is going to move back over here towards the origin. All the other points are also going to shift pi over 2 to the left. So when we do this, something really cool happens. So remember, we're going to follow the path that would have started at pi over 2. So that was decreasing so it looks like this. And you may think that that graph looks familiar, and it should, because this graph is actually cosine of x. So by shifting sine of x by pi over 2 to the left, we end up with the cosine of x graph.